So in this section, I'm going to start with the lab phenomenon of dichotic listening. And I'm going to use a very simple cortical model. There's just three areas detecting receptive fields at three levels of complexity within visual information. These receptive fields can discriminate between types of objects, groups, and groups of groups. Plus, there's a cortical area that detects receptive fields within auditory information at a level of complexity that's able to discriminate between different words. But the receptive fields at this level are detected separately within sounds available to the left ear and sounds available to the right ear. So let's suppose that the red text, "the black dog chased the cat," and so on, is being read to the left ear. And the black text, "the ratio of profits to earnings," etc., is being read to the right ear. Auditory receptive field detections have recommendation strengths in favor of indirect activation of columns in the visual area that discriminate between different types of objects, the semantic memory mechanisms that we've talked about many times before. And the default situation is that receptive field detections resulting from either ear have about the same recommendation strengths. Now, if the subject is asked to pay attention to the text read to his left ear, the red text in this diagram, these instructions result in complex receptive field detections that recommend increasing the activity of subcortical components corresponding with release of left ear receptive field detections to drive indirect activations. So I've simplified that to showing stronger recommendation strengths for left ear receptive field detections. So left ear recommendation strengths will be predominant, and only the left ear text will generate indirect visual activations. The visual receptive fields have recommendation strengths in favor of speech, so the text coming into the left ear can be repeated. And the novelty of the text means that there'll be receptive field expansions, setting up the structure to allow later recall. But the text entering the right ear doesn't generate activity in the visual areas, so it can't be repeated and can't be recalled later. Now, suppose that at the point indicated by the arrow, the texts are switched between the ears. First, let's think about the pattern of activation a little bit earlier, at a point somewhat before the switch, using the approach I described in the lecture on speech processing. At that point, the most recent phrase was "up the tree," so there'll be three populations of columns in the discriminates visual objects area, activated at different phases of frequency modulation and corresponding with the three words in the phrase. In addition, the two previous phrases will have resulted in two active populations in the group of objects area. These have been generated by combining the outputs of individual word populations that were active in the preceding area. At this point, the outputs from the three populations at the discriminates objects level are released to the discriminates groups level, resulting in a third population in that discriminates groups area, and this population corresponds with the overall phrase "up the tree." Next, the release of detections by these three groups populations results in activation of a population at the group of groups level. This group of groups population is somewhat similar to the population that would be activated if the scene described by the words was actually observed visually. And of course, there'll be some receptive field expansions in the visual processing areas, and these can be the basis for later recall. Then all the activity except at the group of groups level is extinguished. So this is the pattern of activity just after the word tree has been heard. A little later in the process, just before the switch, this is going to be the pattern of activity. Activity at the group of groups level, triggered by the first part of the sentence, is still there. There's activity at the group of objects level, corresponding with the phrase "and the cat." And hearing the word "got" has resulted in indirect activation of columns in the area that discriminates between objects. At this point, the words "health" and "stuck" result in detection of receptive fields in the sounds entering the left and the right ears, respectively, which is the opposite way round to the meaningful continuations of the texts. As we discussed earlier, both sets of receptive fields have recommendation strengths in favour of indirect activation of visual columns, but the strengths associated with the left ear are stronger. So on this basis, the recommendation strengths in favour of indirect activation in response to the word health are stronger. However, they aren't the only indirect activation recommendation strengths available. The columns indirectly activated in response to the word got also have recommendation strengths in favour of indirect activation of columns, including indirect activation of columns in the same visual objects area on the basis of past activity at similar times. And the word got has probably been heard somewhat more often in association with stuck than in association with health. Then, the columns active in the discriminates groups area in response to the phrase and the cat also have indirect activation recommendation strengths, and some are in favour of columns in the discriminates objects area. And once again, in the past, phrases like and the cat are a bit more likely to have occurred when the word stuck was also heard. Similarly, for columns in the group of groups area, activated in response to the group of phrases the black dog chased the cat up the tree. So there are three additional sources of recommendation strength that mainly reinforce the recommendation strengths of the sounds detected by the right ear in favour of activating visual columns in response to the word stuck, which is being heard by the ear that up to now was ignored. So it's likely that the predominant recommendation strength will be in favour of the word stuck, and that word will drive indirect activations in the visual areas. In other words, there's a switch to the unattended text. But there's no indirect activation at any point resulting from the black text, so there's no ability to describe that unattended black text or recall it later. In other words, there's no consciousness of the other text. So that's how we can understand the dichotic listening phenomenon at a deeper level of description, and we could of course go to yet deeper levels in ways I've outlined earlier in the course. Incidentally, these additional recommendation strengths can be very valuable for following a conversation where words may be mispronounced and where there may be other conversations going on nearby.